One of the tricky things with SwiftUI or in iOS in general is because we have so many options for choosing between struct classes, enums, protocols, and sometimes it's really difficult to know why you choose what's the disadvantages, what's the difference in general, and in particular for SwiftUI. I have another tutorial about the MVVM pattern in SwiftUI, and I probably didn't, I tried to highlight the fact that some of these parts of view model and model supposed to be one of struct, so views are structs, view models are classes, and models are structs. If you're interested in MVVM, I highly recommend that tutorial. But in this video, I really want to give you some hands-on experience on what can happen when you don't choose this correctly. For the views, they're usually structs, but for view models and models, we have more in our hands for SwiftUI. So first, I will give a short recap or do very quick introduction to the difference between structs and classes. I'm not going to mention everything, mostly the stuff that is important when we go into SwiftUI. And then I show you some examples in SwiftUI. So we try both with structs and classes. And you will see weird things not updating. Maybe you already experienced some updating issues, so I hope I can help you with them. Okay, let's get started. In this case, I'm going to use a playground. I probably should use more. I'm going to use a blank playground. I'm going to start by using structs. So I create here a new playground file. And this is struct example. So I'm not using what is here already. So you would start by creating a struct, for example, for our model files. So this is a very basic item which has a name. This is a var because I might want to change this. And maybe it has an ID. Because I don't want to change the identifier. It's supposed to be always the same one, otherwise it doesn't make sense to have an ID. This is a let and this is a UUID. Okay, now let's create two items. Item number 1, and the name is first, and the ID is just a UUID. Okay, then the second item, I want to start with the same values as my first. So when I create this, I'm setting my second to my first. And then I wanted to change my mind and change the name of my first item to changed. So now if we want to check what's actually in there, so I can print both names. And I should make my item number 1 a var because I wanted to change one of these properties. So I am getting here, maybe instead I use if you have on the right side in the playground, you can click on this pad and then you actually see the value. So that might be a little bit better. So you see that my first item's name is now changed and my second item's name is still first because this is the one that I assigned it to in the very beginning. Let's see what happens with this little code when I do the same as a class. I'm just going to create here a new playground in another page, simply because I want to put it on my GitHub and then you can download it and you have all of the examples. And if I override it, you will see different ones. This is my class example. So it's a bit boring because I just do the same. So I have here a class item with var name, string, let ID, UUID. So let item number 1. Now this is the first big difference. And it finally gives me the error I was waiting for. So classes don't get an initializer per default. You have to write your own. This is name, string, self.id is UUID, self.name is name. So now I have an initializer and I can actually create one of them. For structs, you get a default initializer. And you see here, it's actually just asking for the properties that are in my struct. If you write your own initializer, like I'm just going to use this same, self.name is name, self.id is UUID. For a struct, when you add a initializer, you lose the default initializer. And that's the initializer that I actually used here before. Okay, I'm just going to remove the ID. So I'm using this initializer function now. Everything should work again. You can write obviously a lot of different initializers, but for classes it's quite a bit more complicated, especially if you're going for class inheritance. But you can have convenience and required initializers. Okay, maybe I shouldn't go there now. So we wanted to go for the simple stuff, relatively simple stuff of creating a second item and copying my first one. I mean, that's what I want to do. And then I can change the name of my first one to changed. And then I just wanted to print my item's first name and my item's second name. Okay, so, but things are a little bit different. So let's just now go one by one. The first thing you might have noticed or not noticed, this time I was able to change my name very easily because the class that the instance of my class that I created here, item 1, is a let. But in this case, I was actually allowed to change the name. For my struct, I had to make this here a var, which means that the whole item is variable. And for my class instance, the property here is variable. This is because it's reference type. And when you can change a property inside of a class, and the class instance itself, the one class that you created doesn't change. But for a struct, when you change one property of your struct, you basically create a whole new struct. So that's why you have to make, because you create a whole new struct, the struct instance, item 1 needs to be variable, because that's the one you're actually changing. The whole thing. You're creating the whole thing new. And the class, I really only change the property of the class. So that's why I can still keep my item as a let, but change the name property of this item. Now the second consequence of this is that when I assigned item 1 to item 2, I copied this. I did not copy it. For structs, for the struct example, I actually copied this. So here I create a real copy. Because when I change the item's 1's name, this becomes this changed property, but the other copy, item 2, still has the original value of first in there. So these two names here are different. Whereas for the class, when I do this, assigning item 1 to item 2, I'm just passing a reference. I only have one instance of this item class here. So item 2 is only the reference to the same class, which holds the same properties. Which means that when I change item 1's name, I also change items 2's names because they are pointing to the same original data. When I print this, I'm using the same one class instance's name, which is changed. Now, the other thing, in order to make you believe more that this is actually changing the whole thing, or maybe not, because it really depends if you use did set. So sometimes you really want to know when things change because you want to do something extra. So you can add a did set and will set to properties. I mean, the difference is only, probably I'm going to use will set here because you still have in this case you get the new value. So in case you want to know if things actually changed, you can check if the new value is different than the item. So now I know it's actually changed. And then you can call some kind of update UI function, usually in your code. This is more interesting for people who work with UIKit. This is just complaining because it's not comparable. Okay, I'm not going to do this. I'm just going to print the new value, maybe even with a little bit more interesting will set. Okay, if I run this again, so I'm creating my 2 items. I'm creating a copy for the second one, and then I'm changing here my items 1 name. So this is changed, which is triggering then the will set, which is then triggering the print will set. So this is the first print statement I'm getting here, just telling me that the new item has a changed text, and then only I go for this print statements 1 and 2. So this kind of property observers are very useful when you want to have some kind of observation of your data, your items, and then correctly updating UI. So will set and did set is quite common to use this with UI kit. And then in the class, I just want to do the same. I use here, maybe I just copy the same will set. Okay, this is like kind of an error that is very informative because it already tells me you declared this as a let, so it doesn't make sense to observe it because you say it's never changing. So this is really weird, but it's already telling you that this is already the first hint this is not going to work. And indeed, when I change here the name of my item 1, this will set is not triggered because I did not actually change the item. I didn't change the class. I didn't create a new class instance and assign it to this property. I just changed one of the class's properties. So the will set does not work with this. This is going back to this MVVM pattern. You have the struct and you want to change your UI, your views with this. And in order to have this automatic data flow or view updating depending on your data, one solution is kind of combine a framework with the data bindings, or if you're on UIKit with this property observers, or the classical approach with UIKit in a view controller as the will set or did set. But in order to make this work properly, you just saw I need to trigger my did set, so my updating function is triggered, and that's why I make my model a struct, not a class. Now you see here my view is a struct, my model is a struct, but my view model is a class. This is because you have multiple screens, views, and you're pushing one view on top of the other one. So the view model classes can potentially be shared between different views. So if you are seeing a view where it has an input argument for this view models or the view model, and when you have multiple views that share the same view model, you want to share the same view model, which holds this one data set, and you want to share them. You don't want to create a copy of this view model for each of them, because then they would have not the same data anymore, because one is updating first one is updating its data, and the second one has a different copy of this data. But if you make a view model a class and you are handling the view model to the next view, you're basically just giving the reference to the same view model. You're not creating a second view model. So that's why view models are usually classes. Okay, now let's, after this short theory about SwiftUI, actually see how this is working in a view. And you can actually see that some of this updating mechanism is not working if you're making our model a class and not a struct. So the first thing, because I want to use these items and I don't want to copy them all the time, I'm going to move this item declaration into the source folder. So there's a new file. This is a item class, and then another one. This is an item struct. So I'm only calling this here class and struct because I want to make sure I remember which ones. So I'm copying the class definition. This is the item class. Because I want to use this in the playground pages, I need to make this a public class, and then I have to make the initializer public to also see the initializer, and then I have to make the properties public. Okay, let's see if it's complaining. Yeah, and I have to make this say this is the item class. Okay. And my struct, I'm moving this in my item struct, making this public. Public and public. In my struct example page, I have to make this item struct. Okay. After multiple times of running this playground pages, it's now working again, and I can create another page. And this is my struct SwiftUI. So in this case, I actually need SwiftUI. Also need playground support. Starting off with view. So I'm just going to use this here content view. See this in the playground. You have to call playground page dot current dot site live, and I'm using here my content view. So I'm just going to make this a VStack because I already know that I wanted to display a couple of other data, and then making a frame of 400 and height of 600. The one thing I don't like about the playground is it's not giving so much auto completion. Okay, so in this example we want to use one of the item structs, show this in our UI, and also manipulate this item, and then seeing if it's correctly updating everywhere in our sample code. So I create a state property because I want to change it. So state private var item, and this is a item struct. This is first, and also because there's a couple of different things that can happen and that I can use, I'm going to also add here a number. This is an int, and this is supposed to be a var. I need to make this public, and then starts with a 0. So I have now in my content view this one item, and I can display this. So this is my, just going to say item struct. This is the name, the item's name, and the number, the item's number. So I said I want to change this. So in order to change the name, because it's a string, I'm using a text field. Name for the placeholder, and I'm binding this to my item's name. Text field style dot rounded border, and then a button. And this one is just going to increase this number. And what I'm doing is I'm setting my item's number +1. Okay, and maybe I'm just changing the font to title. And this font dot headline is just so you can see it better for the tutorial. There's no automatic updating, I always have to press this button. Okay, I have two view elements, two texts that just display the data. One for my name property and one for my number property. And then I added these two elements to change the data. So if I change my first name, you can directly see every time I type up here in this other text field, it's also updated correctly. If I press on this increase button, the number that is displayed up there, that is showing what the data actually holds, is every time updated that I press this button. So everything is fine. This is what I wanted. And this is the example with the item struct. So I'm just going to create a new playground page. Maybe I'm just going to note here, this is working update correctly with model struct. So now I'm creating another page with the class SwiftUI, because I'm just going to copy everything. I can show you at the end a very nice thing with protocols. So this is not my item struct, it is my item class. And yeah, I didn't add actually the number here. Public var number int 0. Actually can also do this in the initializer. So going back to my class SwiftUI example. Okay, my error disappears and I can just use the same example. Only this is the item as a class. And we are not sure if this is actually working so far. So the UI is the same, only I'm using now for my data model a class. So I'm changing this here and I'm increasing this here and it does not work. I'm actually changing this and you can see this here because I actually changed it 6 times. But I mean, you saw me copy pasting the code. So the only thing that I changed is making my item a class. So something is not updating. The updating magic of SwiftUI does not work because this item is a class. And this add state is a property wrapper that adds additional functionality. In this case, it's adding for the view a mechanism to know for the view when to update or when to redraw its body, the visible part of the view. And this add state property wrapper uses a did set. Whenever the did set is fired for this property, it tells the view to update. But because we're having a class, as you saw in the class example, this will set or did set never fires. So the view never updates. In order to just one more example, so you can indeed believe me, I'm going to use not here this add state, but a view model, because then I have one tool that I can use to actually force the updating of the view. So again, I create another page. This is the MVVM example. I definitely need SwiftUI. Okay, I'm just going to copy everything again. Okay, maybe I should not forget to say this is not working. So I said I want to use MVVM, so I'm going to move the item into a view model. So this is a class content view model. This is confirmed to observed object. And then I'm going to move this up here, making this a published var. And then in my view, I can use a state object var view model. And I'm creating a content view model. Okay, now all the references I have here are to the item that is my view model. So I need to add here view model dot item. Basically everywhere I have an item, I need to add a view model in front. Okay, in case it's not running, I just experienced an issue with playgrounds, and you can fix this if you're looking in the inspector, so tapping on the sidebar hide and show, and then here under playground settings, you go from iOS, which would run it on a simulator, to macOS, which runs it on macOS natively, and then it does not get stuck so often, hopefully. Okay, now I have this small view, and I can increase this and change it. Okay, this is working correctly. I used again a struct, so things are as we expected. And now I go for a class and I run again. I update, and my text field is actually updating correctly. This is because also in Xcode I managed to have the text field correctly updating, just not the increased number. And the funny thing is, okay, maybe I should have done this before. If I press here on my increase button and then I type in, you see that suddenly my number actually jumps to the new value. It's also updating. This is because when you update the text, the whole body is redrawn. So all properties are redrawn. So it's automatically taking the new value, although it didn't actually know it changed. But I said we can actually manually update this. So I'm just adding another button, and this is refresh UI. And what I can use is, or how it usually works, is the observable object has one data stream to the view, or it's having a publisher. This is the view models dot, and if you look, you have all the items properties, and then there's this object will change publisher, an observable object publisher. And this has one, it's actually a pass-through subject, I think, underneath, if you care about combine. Otherwise, in order to tell the view model that it actually changed, because as you see, it will change, we can use the send method. So we are telling the view model to send to all its subscribers, all its view that it used in, that it changed. So because the view with this at state object property wrapper here actually subscribed to this object will change to check when the view model changes, so it can redraw the body. So I just need to rerun this. Then I can say next. Okay, this is the same. And then when I increase the number, it actually changed it, but it doesn't show it in the UI. And so now if I press on this refresh button, I trigger my object will change, and the number changes to 7, to the new one. I press on increase, it's still 7, doesn't change in the UI. I force to redraw the views, and it updates. So you can see it makes a huge difference if you use a class or a struct for the model or the data that you have. And the easiest way is to go for structs. If you have no choice, and sometimes you don't have it, for example with core data or realm, they are both objects, classes. The normal approach of view models, where you just look at them, it's quite cumbersome because you yourself have to write the code to trigger this view model object will change. And in case of, for example, realm, it's getting even more complicated because they have live data. So the data can change and SwiftUI doesn't know. If you have, for each with a delete, you delete one of these items, and SwiftUI you force the object will change. SwiftUI, it's calling object will change. This is because it wants to calculate the difference. Sometimes you have animation, so it needs to know which views actually changed. And for the animation, it also needs to make a small movie, so it needs to know the first step and the last step, and also calculate steps in between or views in between to show. But in case of live data with realm, you're deleting something, and SwiftUI is trying to access the deleted item object, and this throws an exception in realm, and your app crashes. And it's very annoying. So because of this, it's actually more easy. Instead of handling everything yourself, it's best to use some other property wrappers. This is one of them. This is this fetch request. I need to import core data. And I think it's not going to work. It's going to okay, this error is going to stay. So I just have to deal with it. But you see here, I used a specific property wrapper because this has a lot of functionality in it to check the core data stack to know what's going on. Similar, because then this students or these items always have the right one. It's basically a direct connection to your database. So it makes it a lot easier. For Realm, they did something very similar. They have a property wrapper called observed results, and then you can just say which type you want to observe, and you get all of the types that are in the database, all of the instances of this type in the database, or the one that you have access to, the user has access to. Okay, so I'm going to uncomment this. But this is basically only necessary because of the model are classes. If you're more interested into how the different pattern than MVVM for core data is used, I have another tutorial about this, so I'm going to link this, and also for Realm. But I really recommend to look for different solutions because it just doesn't fit very well with core data, MVVM, and SwiftUI in my opinion. Though this tutorial is anyway way too long. because I have here a little bit of code repetition for these two views, which I don't really like. I prefer to have one content view that I can use for both of these playgrounds we see it. But for this, I need to change here this item. So in my source file, I'm creating a content view. And I wanted to move the content view from here to there. In this case, I need to import SwiftUI. And I have to make everything public again. Public. And I need to have an initializer because I want to give here different items. And in this case, I need to use self.underbar item because I need to initialize with the state and the initial value, which is the item. Okay, and there needs to be one more public. I now can use this view in my struct SwiftUI example. So I can create here, I don't need to use this. Just need to actually have the one item. And then let view is a content view with this one item. And then showing it in my playground. But I only moved the view outside, but it's not really reusable for my other example because I have here a different data type. Actually the other one, the item is also a let view is a content view, item. And then setting this here to my playground. But I cannot give this here because the types don't match. Item class and item struct are not the same type. I'd like to make this more reusable. And this is actually where one of the other features in the Swift language that you can use is protocols come in handy. Because Swift is a strongly typed language, here in my content view, my item needs to have a type. It needs to be something. I can name this here T something, but this has multiple consequences. So first of all, it doesn't know T is a type, so I can use generics. Actually, it's getting more complicated. So I'm just saying here in my content view, I have this T thing. Some type, some is something. Anything, which means my view here complains that, yeah, this item type thing, we don't really know where to get the name from because you said it's something. We don't know where the name is or the number, which means that you need to you cannot just use a generic type. You need to say what you can do with it else. And this is when protocols are handy because with a protocol you can say, yeah, it's pretty generic, but some of the things you can do with it. So let's define this protocol. This is a new file. This is my item protocol. So this is a protocol. Nice. Needs to be a small protocol. Oops. Item protocol. And I said I wanted to make sure that we are exposing the name, the string, and the number. This is the int. We are not saying initializing or creating this number and name here. It needs to know if it's a get or set. It's asking here the property. It needs to know, is it a read-only property or can you read and write? So if you just add in curly braces get and set, it knows it can get and set them. Okay, this is a nice protocol. So I want to use this now in my content view. So I can just say here, my T is something, but this something is something that is conforming to item protocol. And I forgot to make this public. So basically everything needs to be public. This is only for the playground. Or if you have multiple packages. So it's a public protocol. Okay, now my content view doesn't seem to complain because it knows that T is something, but this something conforms to this protocol. And in the protocol, we are saying it has a name and a number. So that's why I can access these two. In my class Swift file, where I had the initial problem that it doesn't like it, I've been getting a new problem, which says item class doesn't conform to item protocol, yet it's true. I said it's the same. So in my item class, I need to just say this class is conforming to item protocol. And the same is true for the item struct. So I'll try again my class example. Sometimes this error is just somewhere to go. But you see my view. And also for my Swift example, it's there. So it's working perfectly. And I could make this content view here more reusable by using this protocol as a type. By using the, actually I didn't use it as a type, I just used it with generic and where clauses. And in this case, I really only needed the protocol to say what I can actually do with this type, this thing, t. Because this thing has a name and a number. You can also add to protocols functions. So this is just increase. And in this case, if you want to change one of the objects, you need to add a mutating. So now, because I said I'm actually creating this increase function. I don't want to implement this for both of them, so I'm just going to say create an extension, because you can, in the protocol itself, you cannot put implementations of this. Extension to my item protocol. And now I can here create my increase function. So I can add here a self.number and increase the number by 1. And I need to add here a mutating before the func. This is only necessary for structs. I mean, if I would have added this function to a struct, I would also have to do this mutating. For class, you don't need to do this. This is public mutating func, which means that because of this extra function, I can also use this in the content view. When I press on the increase button, I can tell the item to increase. And I'm going to show this in the struct example because they actually see something. So I can press on increase and still my number increases. Hopefully. This protocol really helped me a lot in making my content view more reusable, because I used here generics and protocols, and the protocol in this case is just to allow me to reuse the same structures, functions, and to make sure that I can, in this view only knows the properties that are in this protocol, like the name. So this generic type, we can also use where. See, it's conforming to item protocol. And you see it's still working. So it's basically, if you're interested in this kind of things, you need to look at generics and generic where clauses. Because in this case it says, oh yeah, it's very generic, but it conforms to this and this. You can do this and this with this. The nice thing about protocols is you can have a lot of protocols, and you can have classes or structs conform to multiple protocols. For example, I can say this is identifiable. This is another protocol. It's automatically identifiable. Okay, because it needs to have here this ID. But okay, in this case, I need to make it public because the protocol asks for public ID. So here it says, yeah, it needs to have a ID. And in this case, it's only a get property. So there, you already see here it's a public protocol, identifiable, with this one property. If you want to, because you can use different things for this ID, the ID can have different types again. And if you want to have a more generic type for something in a protocol, then you need to use associated types. It's a little bit higher in the complexity. You can see here how it works. The other example is, you see, protocols are actually quite used a lot. For example, if I jump here to the definition of VStack, you can see this working also. So this is the content, this is the VStack, which uses a generic content, so some content. And this VStack is conforming to view, something drawable. And the content that I did, this generic, is also another view that you can draw. Or if you have a for each, it also has here some interesting things. If you jump to for each, I'm looking for, in the documentation for each. and to look for the initializer. And this is a little bit more complicated because you have here a data, and down here you see data conforms to random access collection. So this is another protocol, I think. So basically some array, for example, array is a collection or a dictionary or something. And you see here also it has a lot of constraints to what data it is, this generic constraints. The data's element conforms to identifiable, for example. Or here down, the ID conforms, this generic ID type conforms to hashable, so you can check if it's the same or not. The other protocol that comes up quite a lot is Vue, because Vue is actually a protocol. Here in the definition, public protocol Vue with one associated type body. And it has this one function which is view builder for the body to get this, because it needs to have something to draw. And the reason why the Vue definitely needs to be a protocol is because we have here structs. Structs cannot inherit from other structs. But you can do this with classes. One class can inherit from its parent's class, but only from one other parent class. You cannot conform to multiple other classes. With protocols, you can. You can conform to as many protocols as you want to. You can do this for structs or classes. So it's a lot more flexible than classes and structs, which is why it's so used in Swift. You can find it in UIKit and in SwiftUI quite a lot, to the point that some people actually call Swift protocol-oriented programming, not object-oriented programming, because it relies so much on protocols. Okay, now I will finish with our excursion to structs, classes, and protocols. There's also enums, but they are a little bit easy. Okay, maybe not easier, just on a different level of usage. I hope you enjoyed this investigation of structs and views with me. Please give this video a like and leave a comment if you found something new and interesting in this video, to let me know. Until next time, happy coding.